You give the mean, the standard deviation, you get 0.910. How would I do it if I just had no calculator and I had my little formula packet with my statistical tables? What would I do? I need to find the z-score. So how are you going to do it?
Wait, you said we don't have a calculator?
You don't have a calculator. All you have is a table.
So you take each of those numbers, find how far they are from the mean. And
How do I convert 27 to a z-score? I go z is equal to 27 minus 30 divided by 2, which is negative 3/2, right? Negative 1.5 is my z-score. Then the other z would be 34 minus 30 divided by 2, and I get 2. So on a normal distribution with a mean of 0 and a standard deviation of 1, you're finding that area. Are we good to go? Number 3.
Wait, were we not allowed to use a calculator just then?
I'm just telling you in case, because I don't know which problems you would have a calculator and which problems you would not. All right, number 3. Let me get here. It's 0.00943 kilograms, which is 9.4 grams. Now, I think it's weird that they ask you to convert in there. Okay. Questions on that?
How do you do that?
A factory has a machine designed to produce 1 kilogram bags of sugar. It is found that the average weight of sugar in the bags is 1.02, so let's draw it. My mean is 1.02. Assuming that the weights of the bag are normally distributed, find the standard deviation if 1.7% of the bags weigh below 1 kilogram. All right, so here's 1. And 1.7% would mean that this area is 0.017. And it says find the standard deviation. So I'm going to use that right there. Z is equal to x minus mu over the standard deviation. I need to use my calculator to find that, so I'm going to go inverse normal 0.017. And what do you get? Negative 2.12. So that goes in there. My mean is 1.02. My x is 1, right? Below 1 kilogram. Minus 1.02 divided by the standard deviation, and I solve for the standard deviation. So standard deviation is 1 minus 1.02 over negative 2.12.
So you got negative 2.12 from
Inverse normal
of 0.017.
Good to go? Number 4 is 0.586. And that's basically just using your calculator, right? 5 is 0.645.
Okay, you put these in percentages, right? Is that okay if you put them in percentages?
Yeah, but I would keep it in decimal, 3 significant digits. Okay, and again, 4 and 5, be ready to be able to do those with just no calculator and your statistical tables. Just basically using that conversion thing. Okay? Number 6, A is, the mean is 90 and the standard deviation is 3.7. Oh no, what am I trying to find here? The probability that Z is less than 84 is 0.0524. And B is a rival company produces microchip will fail after 84 months is 0.88. Given that the life expectancy also forms normal distribution with standard deviation, find the mean. Okay. If the probability that Z is greater than 84 is 0.88, then the probability that Z is less than 84 is 0.012. And so I don't have an answer for that. Let me see, number 6.
I did that, like I solved for, I said X was 84, and then Z was 0.12. Is that wrong? Did you, like, to say that?
Well, the answer is, are we doing B?
C.
C.
Not
Did I do B?
No.
no.
Okay, let me go back to B. Probability that a microchip does not fail before the end of the guarantee is required is to be 99%. For how many months should it be guaranteed? So if probability that Z is greater than A is 0.99, probability that Z is less than A is 0.01. And I get 81.4. No. What am I looking for? Find the mean.
No, that's C.
How many months should be guaranteed? 81.4. Did we all get that?
Yeah.
Okay. Now C, they have the probability that X is less than or equal to 84 is 0.12, which means your Z score is negative 1.17, which makes your mean 88.3.
Oh, Ms. Smith,
Uh-huh.
for these kind of problems, since they're asking for like the months,
Did you just,
you wouldn't like have 0.3.
It says except 88 too.
are you inverting?
What are you supposed to put units? Do you mark down, on units?
No, don't you put units unless they ask you.
Okay.
Okay, are we good there? All right, and then 7, a furniture manufacturer. So 7, what are we asking for? 7. All right, the standard deviation is 0.263 and the mean is 9.96. Questions? Number 8. A is 0.894. Yes? All right, you guys, where are we? Did we do these problems?
Yes?
All right, 8A is 0.894, B is 0.118.
How do you do that?
Use conditional probability, and you're doing the probability that X is greater than 55, given that the probability that X is greater than 45.
Yeah, but how do you find the probability that X is greater than 55 and greater than 40?
Well, if it's greater than 55 and greater than 45, then it's greater than 55.
Okay, so,
So it's basically the probability that X is greater than 55 over the probability that X is greater than 45.
okay. And what was the answer?
0.118. All right, 9. A is 134 and B is 484.
44? 84?
Oops. A was 134. Greater than or equal to 525 grams. And B was 484. How do you find B? How do you find the upper quartile?
Good question.
What do you know about the upper quartile?
It's
It's,
mu,
the
or it's
mean-
the mean
The
plus.
median of the first upper half.
Well, in a normal distribution, where's the upper, okay, it's the median of the
So
upper
it's at-
half.
So it's at 0.75.
So it'd be where,
Okay,
Z-score.
0.75, so the area beneath it is, 75% of the data is below that quartile 3.
Yeah.
So on a normal distribution with, when you're using z-scores, you're gonna use inverse normal 0.75. That's gonna give you the z-score for it, and then you need to solve for the raw score. The z-score is 0.6745. So when you substitute that, everything else into your conversion, you get 484. All right, I'm going to go on to binomial distribution, and I want you to go do that practice test. Did we pretty much do the practice test?
Yeah.
All right, did you have questions on it?
Yeah.
On the histogram? Are there other questions? Do you have a lot of questions? What?
Number 4.
Okay, well, I just want to know, I'm not going to go over it right now, but do you have a lot, how many questions do you have, everyone? 2 or 3, 3 or 4? I put the solutions up also, didn't I?
yes, you did.
Actually, kind of a few.
Quite a few?
Well, these, not that many, but like enough.
Okay. What I'd like to do, I think, is just continue going on and maybe answer those questions a little bit at a time, and then give you your test when these guys come back. So everyone can take the test at the same time. Does that sound okay?
Yeah.
All right. So we'll kind of do, we'll multiply